Hi there, JC here. So, this is another episode of Math in Dangerous Situations. In this video, we're going to talk about different professions that can use right-angle trigonometry in cases of emergency. So, the question is, how? First of all, what is right-angle trigonometry actually? Right-angle trigonometry is the ratios of the sides of a right triangle in accordance to the trigonometric function of a certain angle in the triangle. So how could people in a certain professions use right-angle trigonometry to save their lives? Take this as an example. In seafaring, we know that the general rule of all vessels is to get from a port to a port, of course. In this port, there are personnel with radio communications, lifeboats, tugboats, and most importantly, lighthouses. Let's say a fishing vessel is ordered towards a port at nighttime. Unfortunately, the light at the lighthouse has been damaged by a storm a few days ago. Really sorry. So, how do we get to a port safely? Well, we know that the lighthouse is down, so the captain virtually can't see the port. It's really dark and all. However, let's assume that the personnel at port can see the well-lit fishing boat, full with lights since it's Christmas, is it? Well, not anymore. The personnel can, therefore, use right-angle trigonometry to relay the captain's distance from the port. How? He climbs the lighthouse, so let's assume the lighthouse is about 25 meters tall, and he is aware of that height. He sees the ship with an angle of depression of 30 degrees. Yep, measured it, 30 degrees. So, he can now determine the distance of the fishing boat to the port. He shall then use a trigonometric function of his angle of depression, which is 30 degrees. That includes the distance of the ship from port and the height of the lighthouse, which is the tangent function. So, we're going to use tangent theta is equal to height of the lighthouse over the distance from the ship to the port. So, what we need to find is the distance. So, let's isolate the distance and we get this equation. Distance is equal to 25 meters over tangent 30 degrees. Solving that, the distance of the boat is 43.3 meters from the port. There. So the personnel in port could relay the distance to the captain with the radio communications, who is aware of his boat's speed and can estimate the time they would hit the port. And thus, they are saved. There are other situations that right-angle trigonometry is used to save lives. Aside from navigations, let's head to rocket science.
Touchdown confirmed. We're safe on live.
So, what if a group of rocket scientists are to launch an experimental rocket on a slanted launcher? Unfortunately, the automated system used for automatically calculating the trajectory of the rocket is down for repairs, like the lighthouse. We all know bad things happen. So, we know rocket scientists and their due date. The launch has to commence now, or else their boss would fire them. So, there's an 8-meter wall in the path of the rocket, 20 meters away from the launch site. Knowing this, the rocket scientists can tell at what angle of elevation they should adjust the slanted launcher. So, given the distance of the wall from the launcher and the height of the wall, we can use again the tangent function. Alright, so we get this. Tangent theta is equal to 80 meters over 20 meters. So, isolating theta, we get theta is equal to tangent raised to -1, or the reciprocal, multiplied to 8 meters over 20 meters. So, the rocket scientists can then adjust the launcher with an angle of elevation of 21.8 degrees. Their due time is met, their jobs are spared, and best of all, their lives are saved, and the rocket is launched. These are just two examples of using right-angle trigonometry in dangerous situations. There are lots more applications of right-angle trigonometry. I showed you situations that requires a certain distance, which could be related to a side of the triangle, and another situation that requires a certain angle. Both can be determined by right-angle trigonometry. So, math can be a pain in the brain, but it can save your life. Trust me. As always, thanks for watching.